you're participating in the discussion, I don't want any sidebar conversation. You understand? That will be fine too. All right, so if we draw, you take the headphones out. Now, if we look at cobalt, starting with the chart, 1s, 2s, 2p, lines above them, 1, 1, 3, 3s, 3p. If we count, we can only get to 18 electrons. Will that do it? No. So 4s, 3d will get us to 30. Will that cover it? Cobalt had how many electrons? 27. All right. So from there, putting our electrons in, 1 is a full queen. Yes, ma'am. Go ahead. All right, 2s. We got to put 1 down. All right. Now, are you okay with why I did down? They have to spin in opposite direction. Now that 1s is full, the electrons go to 2s. 1 up is it full. Second one has to go down. All right, from there, the electrons have to go into 2p. Now, this is like a 3-bedroom house. These are all of equal energy. They're all at the same level, same floor of the hotel. Electron goes here. Do they want to share? No. It's like you and your brothers and sisters. Do you want to share a bedroom? No, they don't either. One goes here, one goes here. They all take their own room. Now, it's like, Mom and Dad, I had an accident. They don't have the money to build on an additional room, so what has to happen to the new baby or sibling? Somebody has to do what? They got to share. So number 8 has to share with this one. Number 9 has to share with this one. Number 10 has to share. Now that all the rooms are full, now they can go to the next level, and number 11 goes to 3s. 3s isn't full yet, so now number 12 has to go down. Now that 3s is full, now they go into 3p, and again, takes his own room because it's the same energy. 15 takes his own room. But I don't go to 4s yet because the 3p full. No. So that's why 16, 17, and 18 go down because they're not full. Okay? Then up and down. So we're at 20. We have 7 to go. There are only 5 bedrooms. So up, 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 and up. But we have 2 to go. Are we full at 3D? No. So we can't go back to the chart and get the next thing to put those other 2 electrons because 3D is not full. So 2 of them have to go down. So the other 3 are just going to have rooms to themselves. Okay? You see what I mean by the arrows? Yes, we would have 1 arrow. Yes. 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 All right. Is everybody okay with arsenic? Sorry, with cobalt. Can I just add on to this one so I don't have to redo all the work? All right. So does everybody have cobalt? If you check. All right. So if I add on, we have 33 electrons, right? So I'm at 27, 28, 29, 30. So I need 3 more electrons, right? So 4p, how many lines? How many lines go over 4p? All right, and I need 3 more arrows. How am I going to put my last 3 arrows in? The first one is open and wait. Not up and down. Remember, you only need 3, and they're all going to take their own room. They're not going to share because they don't have to share. So that would be arsenic. Question. All right, homework. What 3 did I give you? I remember phosphorus. All right, so phosphorus would be 1s, 2s, 2p, 3s, and 3p. I'm drawing half arrows for these because I'm lucky. And phosphorus, nickel, C4F. How many's in 3D? And I'll be looking at the periodic table. 8. Right? Got it. And what was the other one? Selenium? Alright, I guess we need a 20. 3D. And 4P has what? 1, 2, 3, 4. And there's 20. So there's your homework. Check your answer. Now, these are the first 2 questions of the 2-page quiz. Now, I will not tell you if you need arrows or don't need arrows. You have to know which ones are which on the quiz. So if you forget, and you come up here and you go, Ms. Wallace, this one that has the arrows, I will not tell you that. You have to know orbital notation has the arrows. We're going to learn electron configurations, dot diagrams, and shorthand today. And those are the other 6 questions. Nope. That way you have tomorrow to ask limited questions, and then the quiz is Tuesday. Remember, I'm not reteaching everything from today to tomorrow. We're doing new stuff tomorrow. I mean, I'll be here. I'll be here from 12 to 7. Sadly, if you want to make up a quiz, I will be here from 12 to 7. I will not be here from first period. I'm not required to be here until 12 to 7. It's up to y'all. I will be here from 12 to 7. Let's not get crazy. Alright, are there any questions on homework? So we feel comfortable drawing the arrow. You did the warm-up wrong, but the homework right, so you forgot between yesterday and today?
I know how to do it.
Worries me if you said you did the homework right, but the warm-up wrong. That doesn't sound to me like you know how to do it.
I know how to do it.
Okay. All right. So let's talk electron configuration, because I did these yesterday in 3rd or 4th period. Alright, electron configurations are pretty standard. You will see them somewhere on the final exam. If I had to take a guess, this and dot diagrams are the 2 you'll see. You never know, you might see an electron configuration, but these are easier and shorter to draw, so these are usually my picks. Now, electron configurations only show total electrons in the sublevel. Now, because they only show total electrons in the sublevel, there are no arrows. So, they're a lot shorter to draw, number one, because you're not drawing all the arrows. You're not showing the individual orbitals, so there's a lot less work with them. I prefer them because there's less work. Now, the downside is you do still have to start at 1S. Shorthand, which we'll learn at the end of class, will start at a much different area, so again, there's less work with those 2. Now, let's say that we're going to write, I don't know, silicon. We had no silicon. How many electrons are in silicon? You need a periodic table. How many electrons are in silicon? Okay. So, if we read our chart, what is the first thing in our chart? Okay. How many electrons can go in an S sublevel? So we put a 2 right there to represent the 2 electrons that can go in the S sublevel. Everybody see where I wrote the 2? Okay. What's next in our chart? Everybody see what's next? 1s, and then what comes next? 2s. We write 2s. How many electrons can go in an S sublevel? 2 electrons. Now, if I add this and this together, how many electrons do I have? Okay, it's not hard math. 2 plus 2 is what? 4. All right. Am I at 14 yet? No. So, back to the chart I go. What comes after 2s? 2p. How many electrons can be in a p? All right, so I'll put a 6 here. 2 plus 2 plus 6 is what? 10. I'm not at 14 yet. So, back to my chart. What comes after 2p? I write 3s. How many electrons can go in 3s? I write 2. So 2 plus 2 plus 6 is 10 plus 2 is, I'm almost there. So after 3s comes 3p. All right, now, how many can go in a 3p? But if I say 12 plus 6, have how many? I don't want 18, I want 14. So 12 plus what will give me 14? So I'm going to write 2 right there, so that when I add all these numbers together right here, I get 14 electrons when I add those up. Okay? Question. Yeah. So if I had, let's just say I had phosphorus, which we did last time for homework. Suppose I had phosphorus, which has 15 electrons. Okay? The only difference is I have 1s2, 2s2, 2p6, 3s2. But this time I would need my p to end on what to get 15 electrons instead of 14? I would need it to end on 3, so it ends and adds up to 15 instead of adding up to 14, right? So it can be an odd number. What's on the p? Yeah. Now you wouldn't back here because you need those to be full. You only change the last one that you're getting it to total whatever that atomic number is. Okay? All right, let's try one other one and then I'll let you try. All right, let's do one of those long ones. I don't know. Let's do silver. Silver has 47 electrons. All right, what's first in the chart? 1s. How many? Next. How many go in F? After 2s? How many go in P? So we're at 2, 4, 10. We got to keep going. We're nowhere near 47. So what comes next? What comes after? Well, how many go in 3s? Okay, the 1 is the line. Okay, and that's where some folks have a hard time with this. Remember, 3s has one line. All right, but when we do this, we're talking how many arrows or how many electrons. Okay, so keep that straight. So 3p has how many? Okay, we're at 18, so we're not there. Keep going. 4s has how many? Okay. Now, let's just say for a second that Tyshawn said 40 and wrote 40 on his paper. If he'd written 4D here on a quiz, what would happen to his answer? Wrong. It's completely wrong. Okay? Even if that's just a simple mistake because he wasn't paying attention and he wrote 4D, he gets no credit, even if everything else is right. So be careful. So 4D becomes 3D when he corrects himself, and he puts how many electrons? All right, let's count. 2, 4, 10, 12, 18, 20. We're at 30. Keep going. 4p has how many? 6. So we're at 36. 5s gets how many? So we're at 38. We're getting warm. And then 4D. 4D needs how many to become 47? Because if we add 10 and 38, we're at 48. And we don't want to be at 48, we want to be at 47. 9. 49. Question. Say what? What are you talking about if you go over? Yeah, because 4D9 is not 4D10. It's not over. D can, yeah, not 49. D can have 9 electrons. Yeah. Yeah. Okay. All right. You do for me. Why? Of course you are. Why I was thinking you are. All right. Why Sky is catching it right. What's this? Because P can hold how many electrons? How many electrons do we learn in the quantum numbers P can hold? How many lines could P have on it? How many arrows could it have? How many electrons is that? That's where 6 comes from. Okay? All right, draw chlorine and chromium and antimony. Write those first. Leave a little space because we're going to come back and do dot diagrams. No, the grade's not going to change before you get those 3 down. It doesn't matter. It doesn't matter. Huh? Not much. A line or so. Unless you write really big, maybe 2. Are you kidding? Yeah. No, we're not doing the scatter plot. Okay, I'm glad you played it safe, but no, we don't need that much space. Wait, is that how you 2 if you write really big.
Oh, I like the whole bunch. You were like, oh, it's how much is that?
No.
Wait, so I should be like, side by side.
Yeah, it's closer to it, but it's not that big. Why don't y'all go get some paper over there? There's pens over there, it's your desk. Or colored pencil. The chart with the numbers on the board, so y'all can see it too. I can't see what.
I can't count today.
I have a calculator in the cupboard there. And there will be people on the test who want a calculator to be able to add. They need one. Are you sure? I'll give you a calculator.
So you will always have to work on.
Well, D will always have to. Those will both check.
The students that are going on Mr. Jessup's field trip need to be dismissed and meet in the back lobby at this time.
We all said 9 o'clock. Y'all obey for 5. Well, I can't make didn't follow the sheet. That is true. That is true. What you want me to do about it? All right, come on, it's up. Are you not almost good? Why? line, now look. And I'll probably lose the ones I don't want to lose. Okay. Good. Four, 10, 12, 16. You want to put that? Got it? That's right. Awesome. Back. No, you gotta make it before 17. So what? We have 10. Yeah. Good. How are yours looking? If you guys now decided to figure out. Yeah. How many hours? So Jordan has been out and he's dealt with stuff. I'm saying stuff. The work that Jordan does there. I did the work that Jordan does here. Jordan Square.
Well, I'm trying my hardest.
Yeah, I would work with you. I can't. Well, I can never.
Everyone's going to do
Alright, so we're looking at the answer. Chlorine should be 1s2, 2s2, 2p6, 3s2, 3p5. Alright, chromium should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Everybody got it? Alright, and SB should be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p3. Okay? Everybody got it? The whole thing? After 3p6, 4s2, 3d4. Are we okay on that? Alright, let's talk dot diagrams. Alright, dot diagrams are the shortest of all of them. Okay? Because dot diagrams only show outer shell electrons. Okay? Dot diagrams only show outer shell electrons. Everything else that we've done up to this point show inner shell and outer shell electrons. The dot diagrams only show outer shell. Okay? So, in order to do these, the first thing we need to talk about is what is the difference between inner shell and outer shell. Okay? So, to do this, I'm going to write 3 configurations on the board, and we're going to label inner shell and outer shell. First of all, what is the definition for outer shell electron? outer shell is defined as the highest energy level. Okay? It's defined as the highest energy level. Now, the inner shell is a little easier because it's basically anything that is not outer shell. If you are not defined as the outer shell, you are automatically the what? You're automatically the inner shell. So, I'm going to write 3 different configurations just so you can see some differences in the spacing and where things might be. And I'm going to try to be patient with Ashaya and her slow writing. Okay? I'm going to try. They drive me crazy with this one. All right. Does everybody have the definition? Because I'm going to do it on the next board so it's a little bigger. All right. So let's say that we do sulfur. 1s2, 2s2, 2p6, 3s2, 3p4. And then let's take one like arsenic, like we did in the opening. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3. And then I'm going to do one that's just a royal pain in the butt, which is lead. This one's going to take you a minute to write down. It's going to take me a minute to write. 1s2, 2s2, 2p6. Y'all probably have time up to say it. All right, there's 3 configurations. I'll give you a minute to write that. The whole side of the word. The softer side. All right. Are we caught up? Yeah, we got it out there. Is there my holdout? Anybody need a blue pen? Remember writing this camera? I know this will let someone else. I don't like those kinds. Yeah, hard. Yeah, I'm all.
Oh, hard?
We don't write with a pen. I have a 70, but no, I don't like the pen. I like this one.
I don't know. All the time I like to work with them.
Oh,
You know how you write with a pencil? No. You write with a pencil and it's right all the time.
Got it? All right. So if we look at sulfur, what is the highest energy level? First of all, what tells the energy level? What number? Okay. So when you look up here, I got you. All right, this, and this tell the energy levels, right? Everybody remembers that, right? Okay, I got a lot of dots. That's good. So when I look at that, that tells me the energy level. So what is the highest energy level? The P doesn't tell me the energy level. That's a sub-level. The 3 tells me the energy level, right? So the highest energy level equals 3. All right? So that means this is the outer shell. Okay? Remember, S and P are sublevels. So if S and P are sublevels, you can't go by S and P. You have to look at the numbers. And 3 is the energy level. That means the 1 and the 2 is the what then? There we go. I realize the big mouths are not here, but that means the rest of you guys have to talk to me. They're usually my vocal crowd who will answer all my questions. But that means the vocal crowd who answers my questions is not here. Daniela cannot answer all the questions. You guys have to talk to me today since they're not here, okay? You're on notice. You cannot answer all the questions for them. They have to talk to me today. No, but you sometimes step up and will for them. So, okay, make them answer questions today. Even Priscilla's capable. She just doesn't like to. Okay, keep her head down over there praying nobody talks to her. All right, now, so if we look at arsen, what's the highest energy level? There we go. So 4 is here and there. They're not side by side, are they? No. So those are the outer shell. That means everything else that is not together here is the inner shell. Now, the last one I picked out, lead, and the reason I picked it out is to really illustrate how these things don't have to be together. What is the outer shell in lead? And look at how many 6s you have. And where are they at? They're not beside each other. So here's a 6, and here's a 6. So this is an outer, and that's an outer shell. Okay? So everything else that's there is inner shell. Okay? But my point in that is, sometimes they're like sulfur, right beside each other, easy to find. Other times they might be like lead, and they're not side by side. They're separated by a D and an F. Okay? So don't automatically look at the very end and go, oh, it's just 6P. All right? Make sure you find all the 6s in the configuration. Okay? Everybody got it? Everybody there? Okay, now how do we draw the dot diagram? All right, for sulfur. The dots look like the arrows. So, we have to draw the arrows for the outer shell. Okay? So, draw the arrows for the outer shell only. I'm not going back and drawing arrows for 82 electrons in lead. Okay? That would be dumb. Mario, you want me to have that to the end of the day? Put that. Now, sulfur has 3s2, 3p4 is what you guys said was its outer shell, right? That's all I'm going to draw with the arrows, Okay, if I go right back here, that's what you guys boxed in for the outer shell, right there. That's where I got that from. Okay? So that's what I'm going to draw. I'm not drawing the whole configuration. So 3S has how many lines above it? What y'all do last night in your homework for 3S? How many lines above it? Line. One line. Now, on that line, Ashai, how many arrows did it have? It had 2. And you got how many electrons right there? Those are those 2 electrons that y'all just said. Now, 3P has how many lines above it? That's 3. Now, how many arrows are we drawing on it? Now, how are those arrows going to look is the important part. That's right. You're going to go 1, 1, 1, and then that 4th one has to do what? Go down, which is exactly what Shataria said. The first one's filled, and the other 2 are single. Now, we draw our dots to mimic these arrows. So, the symbol sulfur represents the nucleus and all the inner shell electrons. With me, Ethan? Doesn't look like it. That sulfur represents the nucleus and all the inner shell electrons. We're only drawing the outer shell. Now, don't draw this. I want you to envision in your head a box. Don't draw it. Now, around the box, there could be 2 electrons here, 2 here, 2 here, and 2 here maximum. Now, if you can only put 2 on each side, what's the maximum number of dots you can have?
8.
2, 2, 2, and 2 is how many? 8. So even if you don't know the answer, we are not going to have more than how many dots anywhere? 8. Okay? The answer is 8. No more than 8. Now, I want you to pretend in your head that that box is always there. And you can't put more than 2 dots on any side, okay? It does not matter what side you put the dots on. See how you have 2 dots here, or 2 arrows here together? Pick one of the 4 sides. It does not matter which side you pick. And we're going to draw 2 dots together to represent these 2 arrows. Yes, now you can write. These 2 arrows are what? Together. So pick another side and draw 2 dots together to represent 2 arrows that are together. These 2 arrows are single or by themselves. They're a single arrow, right? So we're going to draw 1 arrow by itself as a single dot, and the other arrow by itself as a single dot. Now, if I had a blank line, what would a blank line mean about one of the sides? Wouldn't have anything on that side. Okay? Are you with me? Okay, that's a dot diagram. So, if we did arsenic. Arsenic has 4s2. What's the wrong way, Dennis? Arsenic has 4s2 or P3. So, how would those arrows look? What would 4s2 look like? And 4p3 look like? How many lines above the P again?
3.
Got it. So how would the 4s2 look? How would those arrows look? Okay. And how would the 3 look on these 3 lines? Singles together. Singles. Okay. So when I go to draw AF, how do I draw my dot? What do I do? Okay, 2 beside each other. This time I'm going to put the 2 beside each other on top, just to show you it doesn't matter where you start. Okay, the other three are just singles around. It doesn't matter. That's why I picked somewhere else to start this time. Just illustrate it, doesn't matter. So if you drew yours like this, and you put your two on the bottom, and then did this, just as correct. Both of those are the same. There's two together and three singles. There's nothing wrong with it. All right, y'all think you can draw lead?
Yeah.
Right there? All right, you draw lead real quick. And then we're going to draw a couple of them you've already drawn in your notes. Go to practice, and then we're going to color code. I got to grab my colored pencils real quick.
That's what I call it. I don't have to work on it. I don't have to do it. Oh, we're down there. I put that there.
Oh my God. All right, did everybody get that? With the arrow? Jordan, am I going to have to come take your phone again? No, but I'm getting ready to. Because I don't think she's texting her mom about her uncle again. And she'll be glad to prove it to me with her text message. Right? How are you? I didn't think. Ah, then we get something with two dots and two single dots and a blank side. Ah, so in your notes, you should have from homework last night, you should have nickel, phosphorus, selenium. What did we do yesterday? Something we did. All right, we did GE, CI. We just did it. All right, do those. Because those are already done. We've already done those in your notes. Okay, because we already have them finished. Yeah, that's what I'm saying. We already did the homework. You already have these drawn. I don't want to have to redraw something. I want to use what you already have so it's faster. Huh? Then there's only one out. You're happy with that? That's my point. The highest is just the foresight. Yeah. Oh, I like it. That's what whole configuration. Then you just have one left. Everybody else. And that's okay too. So these are all left. This is the bottom. This is the top. This is one that's top. Something written on my calendar there.
Before we answer that,
And I'm always still with it. Like, you need to check it.
Still in the west. That was, yes, it was that, or whatnot. Only have more plastic, not that they use the rail, so I don't know. You know, real, and if you get paid off my for this, you're right there. And we can scrap through there and you pick up and you and I will have work. Then I would be nice for it too. Sounds really fine. Alright. We got them? Alright, Jordan, go put nickel on the board. You want to put just for the answer, not all the work. Yeah. Wait, should be laying beside the computer. Unless I put the roll. I usually lay it when it's good in the board. So it can't roll off.
So I just do it over?
Yeah. That's fine. Okay?
I think. Yeah.
Oh, what do you got for 16? I need to see that.
Wrong? I was glad.
We have 2 and 3 T, 1, 2, 3. You wrote 3, 2, 6, you still got 3 arrows. You're going to make those arrows. 6, you got 3, 2, 3. So you got 2, you got 3. Now you're not saying that. Yeah. Okay, now you gotta draw the dots like your arrows. That's why your arrows are. You got 2 together. Yeah. Yeah, so your dots have to match your arrows. Alright. Alright, Danielle.
My stomach is growling.
Where's the? I'm okay with 6-12, but that's the first time in my life.
I mean, you find all of these.
No. No. No, I just don't. I would never stand in line for a day in here with 6-1 stuff. Yeah.
Yeah, everybody,
Yeah, no, I would never go do that. I'm only gonna do everything. No.
Really not worth
My son hates this side, so if we don't eat there that often, it's no.
I mean, I don't give a fuck. They're not worth it.
I don't like that. I don't like that. I don't like that.
All right. Yeah. All right, Mario, go to the PI. Just go, Mario. Mario, go to TI done? How about these? Go to TI. The last two people I asked that hadn't done it. All right, while Ethan's putting TI on the board, just grab 4 colors out of the box.
That's a lot of fun.
4. Look, those are the colors that came in the box. They didn't give me an option to put colors on. It is cool. And once you have your colors, get a periodic table off my desk. Don't color it, just get one. Oh, some nice one.
You know, I always
Well, did they even do that?
Say what?
Did they even do some of kind of stuff like this? Yeah,
Oh,
no,
I graded that.
yeah.
I don't ever have time to like this.
You did great on the 3rd and 4th page.
It was like the beginning part. I didn't
Yeah,
remember.
first and second page.
I didn't remember.
Yeah, but the early part of stoichiometry you did great on. But that reaction stoichiometry was
Yeah,
just
I
bad.
didn't remember that.
Hey guys. They'll be watching that later. They'll see that. It's fire. I feel like if you can look at pins for the camera, all you would see is this one. You get into your phone?
Does everybody have a periodic table in 4 colors?
No.
Oh,
Yeah.
Oh, no. You don't have a periodic table? The colors are in the box. Alright, does everybody have their supplies? Now, we're going to color code the periodic table, Jordan, what's up? Based on the 4 sublevels, okay? Now, do not color so dark, first of all, that you cannot put numbers in, because we're going to put numbers in this very shortly, okay? No. I guess we can, yeah, we can do it that way if you want.
Yes, we're up. We'll do that.
Alright. Alright, so the numbers, since y'all want to do the numbers first, are 1, 2, 3, 4, 5, 6, and 7. Yes, put those on the side. The numbers 3, 4, 5, and 6 go there. 4 and 5 go there. And then some people like to put a 1 out here. I don't typically write a 1 there. But you need 2, 3, 4, 5, and 6 there. Okay?
The ones on the very left,
1 through 7.
Those aren't in the box.
Those are beside. Now, and these numbers, just to clarify based on what we're going to do tomorrow, these numbers stand for energy level. Okay? Because we're going to talk periods and groups tomorrow. And today, we're color coding in energy levels. Okay? Those are energy levels.
And then ones in between.
And those
are in between.
These are in between. They start like before SC, before Y, before LA, and before AC. And then this is, yeah, these are all the numbers. And 1, 2, 3, 4, 5, 6. And then 4 and 5 are before that. Now, I'm going to use 4 colors. Okay? Now, it doesn't matter what 4 colors you pick. They don't have to be the same 4 colors I picked. You just need to make sure that the 4 colors you use are colored in the same places that I colored. Okay? Now, y'all can actually sharpen in the pencil sharpener because I bought the warranty that goes with that. So if it dies, I can return it to Staples and get a new pencil sharpener. Yes, I did.
That's so smart.
Well, I wasn't going to, and the guy said to me, he said, "Ma'am, do you want the warranty?" I said, "What does it cover?" He said, "For 3 years, if it dies, you bring it back, we replace it." I said, "Even if I work in a school and my children sharpen colored pencils in it and it breaks?" He said, "Yes, ma'am." I said, "So, give me that warranty." It was like $10.
Wow.
That's a $45 pencil sharpener. I figured in 1 year, we're bound to break at least one of those. I'll get a new pencil sharpener. All right, so the F block is everything here here, and helium. Okay, now, don't color yet, just pay attention so I don't have to stand, and I'm gonna get out of the way so you can color. Okay?
You have to write S block.
Yes. The D block, I knew that was something. Now, this center section right here is the D block. The P block, oh, this can't help itself.
Oh, that's PDF.
Yeah, there's basically some level. All right, that's the P block. And then the F block is down here. Okay, so just pick 4 colors and make sure they match in terms of coloring. The only thing that causes issues is making sure helium is colored the S block. Okay?
That's the only one.
Now, we should be able to color in 10 minutes. Okay? 10 minutes. This is not a museum piece. We're not framing it and hanging it up. It's a study guide. It's part of your notes.
Yeah, I'm okay.
You cannot use this. I will give you one you can write on. Yes, I do.
What else was it?
I don't even care if you color outside the line.
I was never gonna write this before. But they don't work that way. Yeah, they don't get to you. So it's, I mean, not a good one that's affordable. Like, you know what, I want a electrical hydro. In Martha. Like right now, we have this, pilot system. Like, you know how I'm doing it? They have that, but in highlight. And the highlight.
That's really good on my involved. Saturday night, 2 hours from home. Yeah, I don't want that. They're nice people, but it's 2 hours. We all live here. Kids. Oh. They live in home. We're just driving 2 hours away next year.
Oh, what a new
Why? Place called Catholic Springs. I mean, yeah, but it's 2 hours away.
That's kind of dumb to go to and eat and then come back home.
That's all we're doing. Going in.
Wow.
No.
That's kind of.
I'm done.
I know,
Yeah.
right?
They're old. Yep, they're old. That thing is up for.
Yeah.
And then they didn't make the reservation early enough, so, you know, it's nice early in the day.
Is it
We're gonna do it in
fancy
the dark.
restaurant?
Huh?
Is it fancy restaurant?
No, it's not even a fancy restaurant. If you ever been to a restaurant where there's no menu, they just put food on the table and you that's it. It's one of these, which is fine, the food's good, it's not the issue. It's just 2 hours away. So I'm gonna spend 4 hours going to eat dinner. I mean, and that's just drive time, that's not even the meal. Let me cook it, 7 minutes, for an hour and a half. And I'm gonna drive 4 hours to go do it. It's not. But I don't get a vote. And then my husband's best part is he can tell them no. I'm like, you tell them.
So how was that?
I'm not going to tell you. I'm going to sit here. I'm going to stare at people all day long.
It's over.
And then you know, and where? Yes, C. You mean B? Yes. Hey, I will keep new stuff all day long. New stuff all day long.
I cannot. I'm still on Facebook. Wow. I think over there is one. I'm probably too long. I'm probably going on there. I'm gonna just go in there. I'm sitting on the base. I don't know. Probably. I thought there was I don't know. There is other. Your thing looks like good. I'm always on. I don't even know. I don't know.
Yes, once you have finished, we only code custom schedule tomorrow. And then we'll leave about 11 of them.
Okay, what? No, this is the house. I look at the well, I look at that, that, well,
Just in front, but
these are all these.
that's fine. It's not a challenge. All right, how much more time do we need? I've got right at about 10 minutes. Finish it up, we can start learning to read it. You were going to color for the yellow, going to need color on your own side. That is fine. Just finish it later.
Like, it gets you so mad. Talk about it. I don't like her. It's okay, my mom. I was playing basketball for it, and you never really wanted to yeah, so behind me. Oh, yeah, well, I have a couple of pictures. One of these that well, you all do, well, you know, sit there, break, and watch, and just I'm not even going over these things. It's over, even if it's right. I mean, but we can even cover the.
Okay. So sorry. Okay. Let's talk about how to read this. All right? If you haven't finished coloring, color on your own time. But we need to learn to read. All right. So, yes, I know you know how to read. Most of you just don't choose to read. Now, if we learn to read the periodic table, now, the reason we have to learn to read it this way instead of your trusty chart, you may have noticed that I have, don't write this on your table, but I have stayed out of this range, and all of these elements in our homework and in our practice problems, okay? The reason I have stayed out of that range is the chart of orbital overlap will not work for any of those elements I just shaded in that green color. So those of you who are thinking, oh, I'm not going to learn to do it this way. I'm going to keep using the orbital overlap with the arrows. It will not work for any of the elements that I just colored in that green, okay? So you have to learn to read the periodic table. Now, we're going to do as much as we can. We will need to finish in this class tomorrow, okay? So, first of all, to learn how to read this periodic table, it reads just like the pages of a book. Where do you always start when you read the pages of a book? At the top and at the left, right? Now, first of all, when you're writing down examples, don't write them on your periodic table. Put them in your notes because your periodic table tomorrow might become cluttered and you might want to put some of your notes tomorrow on this periodic table. So let's just say that we write the configuration for silicon like we did a while ago. Okay? Now, if we're doing this, we start at the top left. What is the first number we see? We write 1. What's the block that we see first? So we write F. And how many elements do we have? 1. When we get to the end of the row, where do we go? On the page of the book. Back over to the left, and we drop down to the next row, right? What number do I see? I write 2. What block is this? I write F, and how many elements do I have? I write 2. Keep cruising across the page of the book. What number do I see? What block is this?
P.
I write P. How many elements do I have? 1, 2, 3, 4, 5, 6. I write 6. When I get to the end of that row, where do I go? All the way back over to the left. What number do I have?
3.
I write 3. What block is this? I write F. How many elements do I have? 1, 2. I write 2. Am I at silicon yet?
No.
I keep reading. What number do I have? I write 3. What block am I?
P.
And how many elements do I go before I hit silicon? Hold on. Doing silicon, right?
2.
1, 2. I'm at silicon. I write 2, and I stop. Question. Are you lost? Not a clue. All right. Let's do molybdenum. Molybdenum. All right. Starting at the top. What number do I have first? What block? How many elements do I have? Everybody see? 1, 2. Got it. From the right side, back over to the left. What number?
2.
And what block? How many do I have?
2.
Moving on. What number?
2.
What block?
2.
How many?
2.
From this side, back over, and I have what?
3.
How many? Oh, well, sorry, F. How many?
2.
Cruising over.
3.
What block?
2.
How many?
4.
Whoops. From this side, back over, and I have what?
4.
Block?
Oh, okay.
How many? All right, and as soon as I finish 2, what do I see? I see a 3. So I write 3. And what block is this one?
Oh, D.
So I write 3D. And how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just like we learned D had, right? So I write 3D10. Then there's the 4. And what block is this one? And how many do I have? I write 6. All the way back, I have what? 5F, 2, and then 4D. And how many do I have? 4. You with me? Anybody lost? Feel okay reading it? How many of y'all 6 starting at 1F? Just me? I got Mario at least. All right, can we learn some shorthand? Yay or nay? All right, let's practice. Some of y'all looking at me like I'm crazy. All right, the D right back there. All right. Are you okay with writing them or no? Okay, let's talk shorthand. Now, in order to do shorthand, we have to be able to read the periodic table. Shorthand is also called noble gas configuration. Now, noble gas configuration is based on using a noble gas. So the first thing we have to know is where are the noble gases. On a periodic table, the noble gases are right here. All right, those are the noble gases, in case you don't know that. They're in that very last column. So, we're going to write a noble gas in brackets, and then we're going to write the remaining electron configuration. Now, I will show you how to pick the noble gas in just a second, and then we'll write the remaining electron configuration like we just learned. And it's pretty easy.
Oh, is it like
You would pick like the noble gas before gold, and then just do everything after that till you get to gold. Exactly. Exactly. So it's last. That's why I said, if you're tired of starting at 1S, this will be a shorter way to do it. And I'm tired of starting at 1S.
Is it Nodi?
No D. No more.
Oh.
Okay. Are we there? Yeah. Before I have. That doesn't mean you should be on your phone. Really? There's a clock above us.
He doesn't know how to read that. I know how to read that.
You'll say, you're in an honors class. I would never tell somebody you could not read that clock.
Actually,
I don't want to know it.
We had that whole argument because somebody, just like, within their wall, the time they like, if I want to use this time of day, I don't know how to do that clock.
Okay. I can't think stupid at this point. Everybody should be able to read an analog clock, even though we all use digital more often than not. Now, when you look at phosphorus, okay, we're going to write it in shorthand notation. What is the noble gas before phosphorus? Not after it, before it. Neon, okay? If you can't figure it out, the easiest way to do it is to go to the end and then up one. So the noble gas before phosphorus would be what? Neon. So we put neon in brackets. We're doing phosphorus, by the way. All right, so neon in brackets. That covers all of the configuration up through the neon. We just write what's left after the neon. So, reading from neon after. So if we're here, where do we go?
No.
All the way back to the left and drop down one row, right? So what do I have here? So I write 3. What block? F. How many do I have? 3S2. Then I have what block? And how many do I have?
3.
That is the shorthand for phosphorus.
So, okay, is this right there?
So this would be the same thing. That's phosphorus written out in longhand, okay? This right here is covered by writing that, okay?
Okay, so this is AS.
Uh-huh.
We go over the same thing like we did.
So we do AF. Let's just do it. Okay, so we've got AF, which is right here. Okay, what's the noble gas? All right, we write AR in brackets. And then from AR in brackets, we come back over and we have what? 4F, how many? And then we have what? 3D, how many? 10, and then we have 4P. Yes. And that's shorthand. Now, here's the glitch. We're going to draw in the symbols, but we'll have to learn how to use them tomorrow. You see where it says, and I don't know if this is on your table or if I cut it off. Do you have 57 and 72 written on your table?
Yeah.
Okay. Put a little circle right here and draw an arrow down here and put maybe a square right here and draw an arrow down here. We will have to talk about what to do when you hit that circle and that square tomorrow. Yes. Okay, but you're actually going to have a 5D1, and then you're going to have to go down and read 4F14. Okay? And a 61 can go down and pick up 5F. So it's actually going to split the 5D in the middle and go down and pick up an F block. And there's no way to know that reading that diagonal chart of orbital overlap. Okay, that's the only piece we didn't get to today. All right, does everybody have that before I give you homework? Huh? We will get to it for you. All right. All right, so for homework tonight, for orbital notation, I want you to draw aluminum, and I want you to draw bromine. For an electron configuration, I want you to draw gallium and tellurium. For a dot diagram, I want you to do aluminum and gallium, no, and tellurium. And for shorthand, I want you to do bismuth. No, I can't do that one. It's too far down. No, indium and manganese. The easy one. Okay. Now, your quiz on Wednesday or Tuesday. Sorry, Tuesday. Not here Monday. Will look exactly like this.
What?
Okay. Tuesday. A shot. This is the quiz. The only difference is, yes, G. A. The only difference is the elements will be what? The questions are the same. 2, 2, 2, and 2. Where? TE? I even gave you the same elements. You had to do less work. Breakfast? Yeah. Like where you got to do the dot diagram? I gave you elements that you already did the work for above, so you had less work to do with your dot diagram. Instead of making you have to do the things over again. Still, you want one? Who else wants one? Guy? Daniela? Good. Jordan? Nobody else wants one? Got it. Who loves a box? Oh.
Cecilia Chavez, please come to the main office to sign out. Cecilia Chavez, the main office.